Nostalgia to some, PTSD for others. This panel shows us how to measure distance to faraway objects using your thumb. This was one of the first tricks I learned as a kid, and it made me feel like I had superpowers. So let's assume you are on a field and want to measure your distance to a house across from where you are sitting. What you have to do is extend forth your arm and lift your thumb vertically. Close only your left eye and look through your right eye, and align your thumb with a specific place in the house. For example, the left side of the front door. Once that's done, you switch. You close your right eye and open your left one without moving your arm. And as many of you have tried this trick when children, you will notice your thumb has shifted places. If you followed the instructions, your thumb now appears slightly to the right. Now to the tricky part. You have to estimate the distance that has been covered while switching eyes. In our example, it's from the left to the right of the door. Naturally, you would need some references for this kind of technique, and since the width of a standard door is about 0.9 meters, we will use that. All that's left to do is multiplying it by 10, which is absurdly simple. So 0.9 multiplied by 10 is 9 meters, meaning you are right now 9 meters away from the house. Why it works? Well, it's just simple geometry using the principle of similar triangles. I know saying that might trigger some traumas, but bear with me. The ratio of the width of the door divided by the distance is the same ratio as the length of your arm divided by the distance between your eyes. The latter is approximately 10, because arms are typically 60 centimeters and the length between the two eyes is 6 centimeters on average. Fun fact, using this same technique, which is called the parallax, we could find out our distance to the stars. So instead of the door, look for a star in the sky. Now the thing is, your eyes will not properly work because they are too close to each other for vast distances. We would need observation points much farther apart. The trick is to observe the star and then wait 6 months and do the same observation again. In that period, the star would have shifted places just like your thumb earlier. The reason is because in 6 months, you have moved with the Earth halfway around its orbit, giving us two viewing positions about 300 million kilometers apart. Now measuring stars is not that simple because it takes extreme precision to do that accurately. You would need to notice shifts as small as 1/3600th of a degree or even smaller. How would you notice that? You don't, but a satellite can. It is with this method that the Gaia satellite has measured our distance to more than 2 billion stars in space by detecting stars and then calculating their parallax shifts.